Good morning, everyone. Welcome to the wonderful Gold Coast room. My name is Billy. How are we all feeling after last night? I can see some very energetic people in here. Let's get a woo. Yeah, that's what I thought. So I'd like to bring up Chris and Prescott from COSIV, and they're going to be presenting on SecOps integrations. Please make them feel welcome.
Okay, testing mic. Yep, all good. Thank you for the woo to get us started this morning. Really pleased to be here and talk about security operations, integrations, and automations, something that's near and dear to our heart here at COSIV. Yeah, hopefully we got some good takeaways for everyone from this presentation. I'm Prescott Pym. I've been in the cyber landscape for about 25 years, doing a lot of security operations work around the globe. And more recently, CTI as well. Yeah, like to help teams manage their operations sustainably. Chris?
Yeah, Chris Horsley. I'm one of the co-founders of COSIV. I actually used to work at AUSCERT going on 20 years ago now. It was a very different cybersecurity industry. I also did a stint at JP-CERT in Japan. Hung up my own shingle for a while writing software for incident response teams and SOCs. But yeah, the through line has very much been like this SecOps. Automation, software development, integration. So yeah, really excited to talk about it today.
All right, awesome. So just do a bit of a show of hands here first to get started, but I just wanted to know how many people have a SOC in their workplace at the moment? Just thinking, yeah, it's going to be most people. That's good. And then the next question is, are you already doing some integrations and automation in your SOC space? So yeah, quite a few people. That's good. It helps us tailor some of the presentation today. So I'm going to keep cracking on. So as many of you in the room will know already, when you start out to build a SOC in an environment, usually it's just you've got one guy in the corner. Maybe they were a network engineer, and they're just trying to figure out, well, how do I triage a lot of the logs and find the interesting things that we need to alert on? Typically, into an email system or something like that. So the SOCs typically start very organically. There's not a lot of automation, and it's really just sort of triaging all the information that comes in. Whereas these days, it's very hard to establish a SOC, especially from a greenfields perspective. You've got a lot of different systems and capabilities that you need to work together and integrate, and life can be hell for analysts. You may have a couple of these things, you may have all of these things. There's probably even more that I haven't put up on the grid here. But trying to figure out how all these work together, I hate to say that the single pane of glass is the bit of the nirvana for most organizations. But being able to make your analyst's life easy is what we're trying to target the presentation at today. So SOC automation, it tends to start pretty slowly, and we're going to call that combat scripting. Using some Predator references here, because this is my favorite movie when I was growing up in the 80s, and Chris loves it as well. It's always great to get an 80s reference into a presentation. But typically, in the early days of developing some sort of SOC automation, like myself, back in the day, I was using Perl as a script just to try and automate a few things, figure out how to get alerts going to on-call phones, and that sort of thing. So it's very much just hacking through what you've got with the language that you have at hand, Bash, Perl, Python, whatever it might be. And then over time, that turns into sort of a stealth DevSecOps type capability as you're trying to figure out, well, how can I understand the landscape of my SOC a bit more? How can I deal with some of the alerts that are coming through in a more structural way? How can I make life easier for myself, probably still as the single analyst doing this sort of work, and lay the traps for the predators. Then you start to grow a bit more. You figure out, well, we need to work together as a team. You might involve some people with some development capability. They might recommend, hey, let's use a Git repository to start to store some of our scripts. And Chris is going to go into this in a lot more detail later on. But you can lay down a bit more firepower at this point and clear the forest so you can see some of the trees in the background. The point of this is, I guess, trying to tie in with the presentation theme is we're evolving SOC automation over time from very blunt instruments to trying to get to how can we lay the foundations for what's really a conveyor belt of alerts. And Chris has got some great examples about this a bit later on. So what do you actually want to automate in the SOC? Been working in SOCs for quite a number of years in different organizations around the globe. These are some of the pain points that we typically see with a lot of organizations. I'd say one of the biggest ones is just around ticketing and case management. There's a few different types of solutions out there, like you've got your ServiceNows, Remedy back in the days. You can use things like Sidearm these days to do case management. So being able to get that information and translate it into a central repository where all your analysts can look into it is something that you can definitely, it lends itself well to automation. Enrichment is another one that we love to do, particularly in the cyber threat intelligence space as well. How do you bring disparate sources of information together to make better decisions about the type of incidents and alerts that you're seeing in your environment? So being able to, rather than having to go to 4 or 5 different websites or APIs, pulling them all together in an automated fashion can help make quick decisions about the threats that you're seeing in your environment. Copying and pasting is one that you continuously see in SOCs, where you have a lot of different systems, especially in government SOCs that I've been working in. Sometimes that's just writing it down on a post-it note and then coming over, swivel desking, typing it into another system. Sometimes you can't avoid that in a SOC environment, but being able to automate, say, the transfer of information between systems can make it easier. I've seen many times in an MSSP where the wrong information has been sent to the wrong customer just because of a copy and paste error. So it can greatly improve the quality of your SOC. And where we see a lot of automation happening these days is also around taking actions as a result of your SOC processes. So in this category, I'm going to bundle reporting, follow-up actions on end devices, endpoint protection, where you want to take that information and then quickly make some tactical decisions on the next steps. So what value are you going to get from automation in your SOC environment? A big one is just tedium avoidance. Sometimes your SOC analysts just don't want to do the thing. It's kind of interesting because you also see a lot of neurodiverse people really attracted to SOC-type environments as well. I've worked with many. And sometimes context switching can be really challenging to do. So if you can take away a lot of that context switching from a SOC analyst, they're more likely to be able to drive the right processes and decisions. I already talked about the low error rates for copy and paste as well. I think one thing that is really an intangible benefit is the high-level thinking that you're able to complete as an analyst when you are not being distracted continuously by all the tiny little details you need in the processes. Just enables you to think a bit more strategically about how often am I seeing this alert, and what actions you might need to take from it. Being consistent in the approach for lookups and your methodologies and your processes is also really key, especially in a larger SOC team where you've got multiple analysts who may have different ways of working. If you've got consistent ways of bringing in the data, correlating and analysing that, it can make your SOC much more efficient. And then also storing that information for later analysis and review reporting is a lot easier when you're able to structurally do a lot of this. So what about SOAR? Hands up in the room, how many organizations are using SOAR platforms? Quite a few, that's good to see. SOAR, Security Orchestration, Automation and Response, is one way organizations are trying to tackle this problem by leveraging automation API calls across the environment. SOAR can fill the gaps in these environments, but I'd say it's really critical that you understand everything, the complete landscape of your environment before you start deploying. They can be quite complex to deploy. You've seen a lot of organizations really struggle with making sure they've got the right scripting and automation, integrating all the components. So it can take a while, and you need to understand what are the business requirements and the process workflows before you start to automate and build on those. It's interesting to see in the market at the moment that SOARs are, I guess, more targeted towards security infrastructure automation. There's a lot more generic sort of IT automation with things like Tines, N8N entering the market as well. So there's a lot of choices you need to make about how you're going to do your automation. But for this presentation, we're just going to start to think a bit more tactically and see how you can take some small steps towards automating some of your SOC functions, which Chris is going to talk about. Where do you get the most bang for your buck in automation around the SOC? We feel that the best way you can invest your time up front is around the integrations between all the different components in the SOC. This is a diagram that came out of a report that Splunk put out recently on emerging SOC market trends. And the really worrying part here is that 4% of organizations included in the survey have more than 75 different security tools that they need to integrate together. Must be an absolute nightmare. But even then, most organizations are falling somewhere between the 10 and 75 different types of tools that they need to work through. SOC analysts need to pull information from different systems. So you can see how critical this becomes for organizations to problem solve. Just recently as well, there was a report put out by the team behind the SOC maturity model, which reports on the automation types that are typically found in SOCs. A bit of correlation with what I was talking about here before. Ticket automation is really high, and enrichment are the ones that people are getting the most value out of setting up automations as well. All right, so now we want to walk you through a bit of a case study of something that we've done in this space as well. Are there any organizations who are using MISP here for threat intel capability? Yep, there's a few. We've also done some work around another product called Assembly Line, which is out of the Canadian Centre for Cybersecurity. This is also an open source platform that teams use. Is anyone else using Assembly Line for malware analysis? No? That's great.
Bit of a newer one.
Yeah. So what we did was we did some integration between MISP and Assembly Line to see how these products could work together and efficiently help analysts to drive their workflows. And Chris is going to go into a lot more detail about this now.
Yeah, thanks, Prescott. So I'll explain, I guess, what the use case of this integration between MISP and Assembly Line was, and then we're going to talk a little bit about how we can take some practices in how we might do development in the SOC. And we're not assuming here you're going to have a SAW platform or anything. This is like we said, the Bowie knife, and we're going to try to get to something a little bit better than that. So for those who might not know, MISP is an open source threat intelligence platform. So it collects things like, in its most basic ways, hashes, URLs, domain names. And Assembly Line is an open source malware repository and analysis system. So you can use it to store unique malware samples in a segregated environment, and then you can get it to run through all of these analysis microservices and collect all that analysis in one place and give it a risk score and work out, is it malicious, have all those pieces of analysis stored in a consistent manner. So the problem we had was, in a SOC team, you might have some analysts who should only have access to MISP. That's where they live all day. They haven't necessarily been trained in malware analysis, because to handle malware samples safely, you need some training. You don't want to have these things anywhere near the corporate network, because I think every malware analyst I know from back in the day, they've all accidentally executed a piece of malware they were copying across on a USB. So at all costs, we want to avoid that. So what we want to do is, as hashes come into MISP, we want to be able to say, hey, that hash looks really interesting to us. How can we go and grab that from VirusTotal, if it's there, of course, run that through, or keep our local copy in Assembly Line, do all the analysis, put all those results back in MISP. So those analysts who live in MISP, they can stay in MISP, but they can take advantage of the services Assembly Line offers without having to leave MISP. So the first problem we had was, okay, how are we going to have an interface? Because these analysts aren't going to be able to touch Assembly Line or have a log on. So one thing that MISP does very well is tagging everything. So you can tag events, you can tag hashes. So we came up with a tag that would let you apply to any hash. One thing we wanted to avoid was running every hash through Assembly Line, because that would just burn CPU and our virus total subscription and storage for stuff we're not really that interested in. So we wanted to be very targeted. So by the analyst being able to tag those hashes of particular interest, we could make sure we were constraining it just to the interesting stuff. The second part of this problem was we needed to send that across to assembly line. It goes out to virus total, pulls down the sample. If you've got one of the, let's say, the high tier plans where you can get the samples, keeps a copy in assembly line, and it runs it through all that analysis. So we get a result, which you're seeing on the screen there. The final step, we need those results to come back into MISP. So we had the original hash. Now we want to say, hey, we've enriched that. Now we know what sort of file it is. We know if it's malicious. We know the other equivalent hashes. You often want the whole set of them. And some other bits and bobs like, is this malicious or is it benign, safe, suspicious? As well as a link back to assembly line for those analysts who have the access. So our next problem was, how do we glue these two systems together? There's a lot of patterns you can follow. The first pattern we tried was that after we had tagged all of these hashes in MISP, we ran like a 5-minute batch job. And we said, hey, MISP, give me all the hashes in the last, let's say, 5 minutes that were tagged with that, this is an interesting hash I want to analyze tag. That worked fine at the beginning. The problem was, as the amount of data in MISP grew and grew, we discovered the query it uses to look up all the attributes, all the hashes with that tag, it tends to blow out in time. It doesn't perform very well. So we started to see this integration failing because it just took too long to run, and then they started stacking on top of each other as they took longer and longer and longer. We're going to talk about this later. This is why we need operational monitoring of our integrations. So once we've done the batch job, we go and fetch them. In this case, we send all those to assembly line. Assembly line does its thing, and it has a clever way of doing a webhook back so that we can submit the completed analysis back into MISP. So because this started falling over and it wasn't very performant, we needed a different plan. So what we started doing instead was MISP has a feature called, well, it's got a 0MQ support. And if you've never used 0MQ, it allows MISP to emit events. So as soon as you tag an attribute, it's going to fire an event that we can intercept with software, and we can decide, hey, is this an event we're interested in? Yeah, they use that tag that says we want to do an assembly line lookup. So let's send it right now to assembly line. So this was a big win because we weren't doing expensive queries anymore. It was much more real time than polling it every 5 minutes. So this worked out really well. But it does go to show in this example that once we've built this sort of combat script, I mean, we tried to engineer this very well. We have really good software developers within COSIV. But one thing we learned from this, again, was that operational monitoring. And the first cut of it needs care, attention, upkeep, maintenance, something we're going to talk about very shortly too. So let's talk a bit more about where in a SOC team. So the dream for a SOC team for me is that, of course, you have your analysts. They are the lifeblood of any security operations team. What's perfect is when you have a team of full-time software developers embedded in that team who understand cybersecurity. I've certainly seen it where you have, let's say, organizational developers. So they're not cybersecurity specialists, so they don't know that particular domain. Very good at developing software, but don't have that background. So when we're handling something like malware, we have to do a lot of explanation about, well, what do we have to think about when we copy and transfer these samples around? How does malware analysis work? What sort of data are we dealing with? So it's perfect if you have full-time software developers with cybersecurity experience, more or less sitting beside the analyst team. That's perfect, and I've seen that done really well. What's more common is that it's the analysts who are going to be writing the code. And that's what we're going to assume for a lot of this talk. So that's certainly how it was for me back in the day, because usually the reason I write software or scripts or automation is because I have an itch to scratch. Tedium avoidance. I've always liked the model of we're trench digging. A lot of what we do in a SOC, incident response team, we've got a deluge of tickets coming in. A lot of them are the same. So immediately it's, okay, what can I automate away so it make my job more interesting, do that higher level thought instead of the trench digging work. So we're going to talk about how do you merge being able to do this sort of scripting work and being able to do analysis work. A big problem we do have is that software developers and cybersecurity responders fundamentally have a different mental model. If we're incident responders, if we're SOC analysts, We're waiting for stuff to happen quite often. Alerts flood in, incidents happen. We get a new vulnerability, a 0-day release, and we've got to jump on it straight away. Software developers, when they're working well, need focus. They need to be able to sit down, think deeply about something. There's a stat that's been out there for a long time that if you interrupt a software developer, somebody stopped by for a chat, it takes about 20 minutes for them to reload the context of what they were doing back into their brains. So they need uninterrupted time. Obviously, that doesn't work well with a SOC, but that's the reality for a lot of us, is that we have the interruptions and we want to develop software. So we'll talk a little bit about the least worst cases for some of those. So we're going to look at, firstly, how to improve on some of the worst, how would you say, the worst conditions we find that stop us developing reliable, good software in a SOC. And when I say software, this could be single-line, single-page scripts. It could be web applications. It could be integrations with your SOAR platform. So let's start with the biggest problems, the anti-patterns that we see for automation in the SOC. The first one that is so common, and I also am very guilty of this. I'm guilty probably of all of these sins you're about to hear at various points in my career. The first one is, it's Friday afternoon, things are a bit quiet, I'm going to smash out a script, I'm going to make something better. And I spend an hour, it's a proof of concept script, so I'm cutting corners. I'm not always capturing exceptions. I'm not logging. It doesn't have documentation. But what happens is, and I tell myself that, you know, when I've got time, I'm going to catch those exceptions. I'm going to add the logging. I'm going to make sure it's secure. I'm going to do all those things. It never happens, because next week there's an incident, and the week after that there's an incident, and so on and so on. So that POC script becomes the prod version. That dodgy thing I cut all the corners on, that becomes a critical thing the team relies on. That data feed, the data parser, the enricher. So very often, that fantasy we have that my development prototype will be improved doesn't come to fruition. So we'll work around that. We get a lot of skunkworks development. So I mentioned writing that script on a Friday afternoon. I'm not coordinating with anyone and telling them that I'm doing this. I'm just running a little experiment of sorts and just seeing if this would work. Problem is, again, POC becomes production. I don't tell anyone I'm writing it. I'm not writing any documentation. I know how it works. Why would I want to document that? The problem we have is that has a very low bus number of 1. Bus number being, if that one person got hit by a bus, we can't operate the script. We don't know what it does. If it breaks, maybe I'm the only person who can fix it. Very common in SOCs, undocumented scripts supported by one person. Another classic is I'm building this software on my laptop, my corporate laptop, let's say. Nothing wrong with that. That's where a lot of developers do their work. Problem is, I'll just run it there for the weekend and we'll see how it performs. And then I come in on Monday and I have a look. Again, POC becomes production. It keeps running on my laptop. What happens when I get a new laptop? The laptop blows up. I move to another section of the organization and my privileges change. Or I leave the organization one day. Well, my script effectively leaves the organization too because my laptop isn't running anymore. So we're really running production software on what's a very unstable environment. And we often joke about MISPs running under desks. I'm not going to do a show of hands on how many are doing it. I don't want to ask you. But yeah, you see that a lot. People running even whole systems just on spare hardware running under their desk. Another big problem. Because we are so interrupt-driven, we're always, in my experience, overly ambitious about what we can get done in an amount of time. So I'm there on Friday afternoon, I've got the POC, I'm going to improve it next week. Next week, I get smashed by tickets, smashed by incidents. Very hard to time manage. So a big thing we do for full-time software development is we make, sprints are a common thing. We're going to have 2 weeks, we're going to try to get this much done. That's hard to do when you can account for all the hours in your day. What about in a SOC where half my hours just get blown out of the water by something unexpected that happened? So time estimation is hard, energy is hard to estimate. You need to be on the ball for software development. If I'm running an incident, highly stressful, I'm probably not going to be in the mood to be sitting down and doing that kind of high cognition focus work. Another one is we put the script into production, or maybe it's still running skunkworks-like on my laptop. We're getting the alerts at the beginning, or we've got a script that acts on an alert or produces a report every day. 7 months later, somebody goes, hey, we didn't get one of those reports for a while. Remember those reports we used to get? or we didn't get one of those alerts. Are we smashing security and we secured everything so hard we don't get those alerts anymore? Or did something just break? And we are just oblivious to what's been going on for the last 7 months. And I'll leave it to you to guess which of those two it's more likely to be. So we need a way to know that these automations, integrations, scripts are still running in the way that we thought they would be. And we're going to talk about some patterns for that later too. So there's more sins we could talk about, more problems about that SOC environment that isn't conducive to software development. Let's talk about how full-time software development teams do this. And we're definitely not going to suggest that we're going to become a software development team because, again, we have a different mental model. We're very interrupt-driven. But what's that low-hanging fruit that we can take from full-time software developers that we can employ, best bang for buck, what's going to help us do more reliable software? So there's 3 themes we're going to touch on. The first one is, how do we consistently test what we're doing, testing how our scripts work? The second one is, how are we going to make the operation of these scripts more reliable? So when they break, and they will, how do we know that just happened? And the third one is, how are we going to actually not have these running on laptops, not having this sort of POC skunkworks environment? How are we going to get it out there deployed in a reliable way? So these are the 3 we're going to touch on. So when I started my IT career, and this was in the late 90s, testing was done by humans. And they literally had big spreadsheets, and they had the names of test cases, and they had inputs, expected outputs, pass, fail, maybe some notes. And every time you released a new piece of software, they did it all again, and they literally typed in all of the inputs and read all the outputs, and it was very time-consuming. We often don't do this in the sort of stuff we build in the SOC, but we need to, and there are ways we can do it because we have some automation on our side these days. So a bit of a story here. I did a project at QUT in Brisbane, and they've got a thing there called the Cube. It's a big wall of touchscreens. It's really cool. And we built some software that you could run on these walls, and they're all different projects. One was a map, one was like a productivity kind of cool thing. You could make images sort of sprout out from the screen. We wrote a load tester for these walls because we wanted to make sure that you can do 40 touch events for each of these screens, and I think there were about 20 to 30 of these screens. So we want to make sure that our scripts could handle that kind of load. Our load tester script ran. It ran really well. We were really happy with it. The very first bus load of 9-year-olds got off a bus. They came in to the Cube, into QUT. They smashed it in 30 seconds, just them touching the screens. The whole thing just collapsed. So our testing was insufficient in this case, even though we tried to do the automated testing here. But it does show the importance of both automated testing and real-world testing under real conditions too. So if you haven't done a lot of automated software development, this is really something that you can start to do. And in the age of LLMs, like, we're not going to get into the whole thing about vibe coding because that's a whole other presentation. But one thing LLMs generating code does very well is generating test cases. If you've never done automated software test cases, it's really code that runs your code. And instead of the tester with the spreadsheet going through and typing each of those inputs, looking for the output, you've got code that says, run that function, put in a 1, I expect a 2. Now put in a 2, I expect a 4. Do a 3, I expect a 9. Now, whenever you make changes to your software, you run all the tests again. It might take somewhere between 10 seconds, could take half an hour, depending on how many test cases and how complex. But you can make changes with confidence that you didn't break anything major. We rarely have this stuff in the sort of SOC scripting automation that we do. We make a change, we do like maybe a couple of tests and a half-hearted try, and then we kind of yeet it into production, and we're really hoping it doesn't break. So there's 3 main types of testing. Unit testing is typically, we're going to run that function with a 1 and a 2 and a 3. We're going to make sure all that matches. So you're testing the function in isolation. Integration testing can be, well, let's run that function and that function together, make sure they are the right contract. The software contract is upheld between those 2 things, or it could be 2 components. And then end-to-end testing is we're going to run the whole system, try all the different logic paths, make sure everything works okay. So if you were starting to automate, I would tend to focus on unit integration testing. End-to-end can be complicated for reasons we won't get into so much. But yeah, we can get LLMs to test our code. every time we make a change, we can run the test suite, and if you've got a CI/CD pipeline, another topic for another time, we can make sure every time we release new software, the tests get applied, we will see breakages. So I highly recommend going and learning more about this. One other very good technique for a SOC is what we call mocking, because a lot of the times we're writing integrations that are reaching out to other systems. What we want to do is simulate the other system, because we might only have one production version of ServiceNow, and I don't want to make 1,000 tickets while I'm testing my software. Mocking lets me simulate the response from ServiceNow. And pros and cons, because ServiceNow might change the way it does something that my software no longer understands. But yeah, have a look at mocking as well. Very useful technique. We talked about reliable operations. If our script breaks, how do we know? One is logging. If there's errors in the logs, if it's a script throwing exceptions, we need to know that happened so we can jump on it. Second one is, if we're expecting a daily report, do we have a watchdog process that's going like, hey, you didn't get a report yesterday. Something obviously broke here. So the watchdog style you pick is going to depend on what your script does, but something that's overwatching what you're expecting to get from this integration, automation, whatever it is. The other one I see that gets forgotten a fair bit is backups. We tell everyone else to back up, but when we get our integration, our script into production, we need to back it up. That includes the software, the configuration that might be unique to production, any data it produced, any logs it produced. Once we deploy and we're not backing it up, if that system gets blown away, if the VM gets shut down, we've lost all of that. So we also need to think about, all right, are we backing that up nightly? And it's something that sounds obvious because we're always preaching it as security responders, but you so often see it doesn't happen. Reliable deployment. How do we do that? So we talked about you've got your POC script, we need to get it into prod. How do we do that in a way where we're making sure that what's in prod is going to run well? The first thing is to automate how we deploy. So again, a sin I've been guilty of, quite often we've got our development environment, and let's say it's a PowerShell script. I copy it across to my production system manually. That works fine for now, but what happens when I've got a config file? What happens when I've collected some log files? What happens when someone who isn't me does this, and they've got a different account? Before it was running as me, now it's running as them. If you don't change the permissions, the script will fail. It'll say something like, oh, I can't write to those logs, they're not mine. I can't read that config, I don't have read access. You have to automate this, because otherwise, and do it from day one. Don't automate it later. Your very first deploy should be automated. That way, every time you deploy, it's a reliable deploy. As soon as you start manually doing these things, you're asking for trouble. Speaking of which, the other bad pattern you see is that we've got the script running in prod, there's going to be a bug, and that's fine. We expect to have bugs, improvements, and all the rest of it. So a helpful member of the team looks at prod, they look at the logs, they look at the data coming in, they work out the problem. They make an edit to, let's say, this PowerShell script in production, it's working, great. 2 weeks later, we've forgotten that somebody made this prod edit. Somebody makes a change to the development version. They copy it into prod and clobber the change that somebody else made, and the bug comes back. So there has to be a hard and fast rule. We never edit in production. If we're going to fix a bug, we fix it in development. We use our automated deployment. We get to prod. And it has to be ironclad. We always follow that process. As soon as there's exceptions to the rule here, again, we get breakages. We get unexpected operational instability. The third point we'll make about reliable deployments, let's say I've got 3 developers in my team that are maintaining this script. So you've got a copy, I've got a copy, someone else has got a copy. I make a change, this is version 1, I push it up there. Developer 2 has a great idea to add some new support. They push their version up there. Now I make a change, I add another feature I would like, or a bug fix, I push mine up, clobbering developer 2's. So we need to be versioning and be able to track the versions getting deployed to production. And luckily for us, there's a really good answer to all of this, and it's called Git. How many people here use Git or know about Git? Yeah, that's a decent showing of hands. So Git is fantastic. It can be a very complex beast, but there's a handful of commands, and if we just use those, we can get really good benefits. So basically, you're developing a new thing on your workstation, you create some files, you create some code, you create your PowerShell script, you run git init. It does some magical things that makes all the Git metadata happen. You add a remote repo. That's where we're going to push our code to. GitHub, Bitbucket, two classic examples. We're going to change code. We're going to add it to the Git repository. We're going to commit it with a description of what we did. We're going to push it to our remote repo, repeat and repeat and repeat. And we can track every single change when it happened. We can tag releases. We can have our 3 developers all collaborating, because Git understands how to deconflict those changes, or it will warn you when it can't do it for you. So Git is very lightweight, very easy to use. This handful of commands will get you a long way. What's on the screen there? I think the slides will be available somewhere, so don't worry too much, but spend half an hour if you've never used Git. Go back, learn that handful of commands. It's lightweight, quick to get going, and it's amazing bang for buck when it comes to tracking how you develop software, even if you're solo. Start using it today. The other thing it does very well, it gives you backup for your code. So within Cosive, we encourage people to commit often and to push all day, every day. We don't want to be working on our workstation for 2 weeks on all these amazing changes and the hard drive blows up and 2 weeks of work has gone. If I'm pushing into Git, let's say hourly, that's the maximum amount of work I'm going to lose. So, if you aren't scripting in your SOC yet, or you don't have a standard, the team hasn't agreed on how to do this, and there's lots of languages to choose from. In my opinion, you should choose Python. A few reasons for that. First is, Python's been around for a long time. It has an amazing collection of libraries. It's on, they have a service called PyPy. It's got something for everything in data science, in machine learning, in bioinformatics. If there's a library, you will find it on PyPy. And you just bring in that library and you are getting the wealth of worldwide knowledge on how to do a lot of automation work. The second reason I recommend Python, I can do just about anything I need to SOC-wise in it. Obviously scripting, I can build a big application, something like assembly line. I can run it as a Lambda on AWS as a serverless function. I can write a complete and complex web application using it. I can write a plugin for a lot of the systems we use. MISP uses Python plugins. Assembly line uses Python plugins, but so do many, many other systems. It's a very common language. Also, quite a bit easier, I think, to hire for developers who are analysts who probably have Python skills too. We don't want to go do anything sort of a bit too unique here. We want something very common. Runs on every operating system that you're probably using. Excellent for data analysis. There's a great Python notebook. So there's Jupyter is a big one. I prefer one these days called Marimo, and there's some really good advantages, including very good integration for data analysis and data visualization. If you're into the LLM AI scene, Python is a very commonly used language in that space too. So I find it's the language I can break out for just about any problem I want to deal with. Not the most performant language, so you may not want to always use it if you need something really, really high performance or that's munging a lot of data. So if you're using Python, and I know a lot of you are already, here's a few things you should be doing, or if you're about to use Python, you should do these from the get-go. First one is called virtual environments. These are lightweight, disk-based mechanisms that let 2 Python scripts run on a system without treading on each other's toes for things like libraries and version conflicts. They're very lightweight, easy to spin up, so please go and have a look at virtual environments. Use typing. So Python is what we call a weakly type language. That means when you declare a variable, you don't have to say this is an integer or this is a string. You just say it's a variable and Python works out what to do with it. The problem with this is you can pass a string into a function that's really expecting a number. Sometimes Python won't know what to do with it and it'll throw an exception. Other times it will just do unexpected stuff. Python has something called type hints, so you can say, yeah, this should be a number. This should be a string. Out of the box, it doesn't enforce it though. But you can use these 2 tools. One is called MyPy, been around for a long time. The other is called Ty. This is in alpha, but I think it's really good. Written in Rust, very, very fast, much faster than MyPy. You can run this over your code base and it will warn you or error on you if you are doing the wrong thing, you're mixing types, doing something inappropriate there. So you have to declare what type all your variables are. This gives you a lot more reliability for your scripting. And it's something that other languages like TypeScript do out of the box, but we can kind of do it in Python too. Testing. As mentioned, automated tests, brilliant. PyTest is a good place to start. There are other testing frameworks too, but get across one of these. It helps you with a lot of the structure of how we're going to build those tests. So the new hotness in the Python world is this thing called UV. Also written in Rust by that same team as Ty, in fact, and it does a whole bunch of great things. Really fast. The thing I like about it the most for our tactical SOC stuff is that I can write a one-file script. I can declare the dependent libraries. The first time I run it with UV, if I don't have the libraries, it will pull them in about a second, install them, set up a virtual environment, run the payload. The second time I run it, it won't worry about pulling those in anymore. So UV, if you haven't seen that and you're doing Python, check that one out. Pretty new, really good. So this is really where we want to get to with our model. Many SOCs are starting like on the left here. It's all unmanaged. It's a jumble. If you can get from there to the top right, a single conveyor belt, we've got order. We're using Git. We've got reliable deploys, doing very well. Ultimately, you want to get to what the bottom is, using a SOAR platform. We're orchestrating and enriching everything that comes through the SOC. But we've got to start somewhere. So if you can get from the left to the top right, you're doing really well. Thank you very much. This is Prescott. This is me. I don't know if we have time for questions or have a chat afterwards.
Unfortunately, we are out of time for questions, but if you did have questions, please meet them outside, and I'm sure they'll be willing to answer them.
Sure. Thank you very much.